Graph the following absolute value function. F of x equals the absolute value of 2x plus 1. State the domain and range. There are two common methods used to graph an absolute value function. First, we can graph the function within the absolute value symbols and then reflect any portion of the graph that is below the x-axis corresponding to a negative y value across the x-axis, making the y value positive. This can only be used, however, if the entire function is within an absolute value symbol. As an example, y equals the absolute value of g of x. That's what we have in this particular question, and so I will be using this method for this question. The second method that is possible is to break up the function into two or sometimes more pieces. This is called using the piecewise method. The pieces that we break it up into are based on the sign of the expression inside the absolute value symbol. As an example, for y equals the absolute value of g of x, we would plot y equals g of x for any x values where g of x is greater than or equal to 0. We would plot y equals negative g of x for any x values where g of x is less than 0 or negative. This method can be used even if part of the function is outside of the absolute value. As an example, if we have y equals the absolute value of g of x plus f of x, note the f of x is not within the absolute value expression. Something like y equals the absolute value of 3x minus 2 plus 2x. For this example, I'm going to be plotting y equals 2x plus 1, initially ignoring the absolute value symbol. Note this corresponds to a straight line in slope-intercept form. This means that the y-intercept is equal to 1. I will then first plot that point with a y-intercept of 1. The 2 beside the x corresponds to the slope of this line. That means as we go up 2, we would go right 1. Or we could go down 2 and left 1. We can then draw a line through these points corresponding to a slope of 2. Note here that to the right of x equals negative 1/2, all of the y values are greater than or equal to 0. That portion of the graph will remain unchanged. X values to the left of negative 1/2, the y values are negative. We then have to reflect these across the x-axis, making all of those y values positive. Then for the graph of y equals the absolute value of 2x plus 1, we get the green graph. As for stating the domain and range of this absolute value function, for the domain, this corresponds to the possible x values. Note there are no restrictions for the x values. This means that the domain is x is an element of the set of real numbers, or XER. As for the range, in this particular case, the y values are always greater than or equal to 0, so our range will be y is greater than or equal to 0, comma, y is an element of the set of real numbers.